Put down your highlighter right now. Reading your textbook over and over isn't going to save your grade in Cambridge IGCSE physics. Today, we're stepping entirely out of passive reading and straight into elite exam strategy for syllabus 0625. If you want to survive the examiner's red pen, you need to know exactly how they think, and more importantly, you need to know exactly how they trap you.
Let's start this off with a high-stakes challenge. 3 doors, 3 answers to a standard energy efficiency calculation. Door A gives you the final percentage, but it's rounded to one significant figure. Door B gives you the raw decimal, but completely forgets to state the formula. Door C states the formula, shows the substituted values, gives the exact percentage, but forgets the percentage sign. Lock in your answer in your head right now. Think about the mark scheme. Which one of these guarantees full marks? A, B, or C?
Well, if you chose any of them, you just lost marks. None of them are perfectly correct according to the absolute strictest examiner standards. And incredibly, only 12% of students worldwide navigate these calculation traps perfectly on their very first try. The rest just bleed marks, dragging their grade boundary down from an A star to an A or an A down to a B. Okay, let's dive into this and fix it right now so you aren't part of that statistic.
Directly from the Cambridge coursebook contents, we are hacking Chapter 6, Energy Stores and Transfers, and Chapter 8, Work and Power. These chapters are notorious. Students tend to think that just because they know the basic definition of kinetic energy, or because they can recite the equation for work done, they're perfectly safe. But ordinary textbook revision of these chapters is simply not enough to secure top-band marks. The traps aren't buried in the definitions. They're buried in how the examiner asks you to apply them in complex, multi-step scenarios.
Section 1. The painful reality. Why ordinary revision fails. There is a massive gap between understanding a physics concept in your head and actually surviving the examiner's rigorous mark scheme. You can know the physics perfectly and still score a flat 0 on a 4-mark question. Let's break down exactly why that happens.
Here are the 6 most common mark drainers straight from the source. 1. Missing units. Leaving the joules or watts off your final answer immediately drops a mark. 2. Rounding too early in multi-step calculations. If you round your intermediate answers to 1 decimal place, your final answer is going to be completely skewed. 3. Vague explanations. Saying it gets hotter instead of internal energy increases just doesn't hit the specific command words. 4. Graph axis errors, like accidentally swapping the independent and dependent variables when analyzing power output. 5. Weak practical improvements. Writing "do the experiment better" won't score anything. You need specifics like insulate the beaker to reduce thermal energy transfer. And 6. Using the wrong variables entirely. These specific errors will completely destroy your marks, even if your fundamental knowledge of energy conservation is rock solid.
In a moment, I'll show you the exact examiner clue that changes your answer completely. But first, you really need the framework that makes that clue obvious. If you tune out now, you're going to miss the ultimate mark scheme secret that actually separates the A stars from the Bs. This is literally the engine behind a perfect paper.
Section 2. The high mark answer framework. To stop leaking those marks, we need to completely rebuild how you answer questions. This is your ultimate exam hacker strategy to build bulletproof, top-band answers from absolute scratch.
Now, what's really interesting about this slide is how this framework completely overrides vague textbook waffling. You follow 4 distinct steps. Step 1. Concept. State the specific physics law you're using, like the principle of conservation of energy. Step 2. Evidence or data. Pull the exact numbers or observations from the source material provided in the exam prompt. Step 3. Scientific reasoning. Connect your data to the concept using a clearly written equation. Step 4. Examiner wording. Package your final answer using the exact terminology the mark scheme demands. No slang, no assumptions, just pure, precise physics. Section 3. Fixing a flawed answer. Energy conservation. Let's put some stakes on the table and actually apply this framework. We're going to look at a real-world scenario where a student attempted to explain an energy transfer for a falling object and completely missed the mark.
Take a look at this flawed student answer. It gets faster so energy goes up, as seen in the numbers. This is a total disaster. It's incredibly vague, the conclusion isn't explicitly supported by the data, and there are absolutely no units or equations to back up the claim. The examiner gives us 0 marks. Now let's deploy our framework instead. Concept: gravitational potential energy converts to kinetic energy as the object falls. Evidence: we note the specific mass of 2 kilograms and the height of 5 meters straight from the prompt. Reasoning: we state the equation clearly. mgh equals half mv squared. Examiner wording. We substitute the exact values, showing our working step by step, and attach the correct units to the final velocity. That improved right-side answer secures every single method mark available.
Section 4. The Ultimate Physics Challenge. Okay, you have the framework. Now it's time to test if you can actually use it under real pressure. We're pivoting to an interactive challenge to see if your newfound ability to spot examiner traps holds up in a practical investigation scenario.
So the crucial point lies right here in this mock data set for work done versus time. I want you to mentally pause and really analyze these numbers. Pay close attention to the raw decimals for time, say a recorded value of 4.7 seconds, and the variables being measured to calculate power. There is a lethal trap hidden right here in how a student might use this data to draw a conclusion.
The student looked at that data and concluded, because the time rounded up to 5 seconds, the power output was exactly 20 watts. Spot the error. Why does this conclusion absolutely fail to earn the final evaluation mark? Think back to those mark drainers we discussed earlier. The student rounded the time variable from 4.7 to 5 seconds way too early, right before calculating the final power output. Because power equals work divided by time, that premature rounding creates a massive cumulative error. Their definitive conclusion of exactly 20 watts is entirely unsupported by the precise raw data. They just threw away a crucial evaluation mark for absolutely no reason.
To make sure you avoid that, here is your examiner-style correction checklist. Do not turn to the next page of your exam booklet until you've mentally checked off these 4 boxes. 1. Did you show your substituted values clearly so you can grab those method marks even if your final calculation is wrong? 2. Are the correct units present on the final answer? 3. Did you use the appropriate significant figures, which is usually 2 or 3 in Cambridge physics? And 4. Reasonableness. This is vital. If your calculated power output for a small battery-operated toy car is 10 million watts, you've made a colossal mistake. Always check your reasonableness before moving on.
You now have the ultimate defense against energy and work traps. But here's the terrifying truth about the real exam. Cambridge rarely tests these chapters in isolation. What happens when the exam blends energy with a totally unexpected, unrevised topic from Chapter 11, like thermal physics, throwing specific heat capacity directly into your mechanical work calculation?
That's the real trap. Remember the 3 doors from the beginning? Door 2 opens in our Physics 0625 Last 7 Days Revision Map Explainer. If you actually want to survive the final exam, mapping out these blended, cross-chapter topics is your absolutely mandatory next step.
You cannot afford to walk into the exam room without knowing exactly how these topics connect. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click the explainer on your screen right now to unlock that final 7-day revision map. The examiner has set the traps. The question is, are you ready to walk right past them? I will see you over there.